Welcome to my YouTube channel. My name is Likith from Sri Venkateswara College of Engineering. I am from Electronic and Communication Engineering. So today's topic is writing a Verilog description behavioral of JK, RS or SR, T and D type flip-flops. Introduction. Verilog standardized IEEE 1364 is a hardware description language used to model electronic system. It is most commonly used in design and verification of digital circuits at register transfer level of abstraction. Flip-flops are fundamental building blocks in digital circuit that can store a single bit of information. They are used to store state information and synchronize this transfer of data between different parts of digital system. In Verilog behavioral models contains propositional statements which control the stimulation and manipulate the variables of data types. These statements are contained within the producers. Each produces as a activity flow associated with it. So let us learn first what is JK flip-flop. JK flip-flop are the fundamental building blocks of sequential circuits. FF flip-flop can contain 1-bit data, hence it is known as a memory cell. Since they work on application of clock signal, they come under the category of synchronous circuits. So JK flip-flop logic symbol. So we have two inputs as J and K, and we have one clocked which is turned on whenever it is needed. So we have two outputs Q and QN bar. So this is the table of JK flip-flop. So behavioral model of JK flip-flop. Behavioral model is the highest level of abstraction liking gate and data flow modeling. Behavioral modeling does not demand knowing logic circuits or logic equations. As a designer, we just need to know the algorithm behavior of how we want this system to work. This type of modeling is simple since it could involve using complex circuits. So when it comes to JK flip-flop, JK flip-flop has two inputs and two outputs. So we can see the truth table out here where we have when both the inputs are low, there is no change. Like there is no change means the previous state lies there. When J is 0 and K is I, we will get 0 and 1 as our output. So it is preset state. When J is high and K is 0, we'll get 1 0 and it is a set state. When both are high, we'll get toggling state. To undergo this toggling state, we undergo the raise around condition. So let us learn about SR flip-flop. SR flip-flop or set reset flip-flop stores 1-bit data. It can store 1 or 0 to flip-flop by applying input according. If S is 1, R is 0, it stores. If S is 0, R is 1, it stores 0. In tutorial, we will describe the SR flip-flop in variable Verilog HTL. You can see the true logic diagram of it, where S and R are the inputs of the flip-flops, where output is Q and QN bar. You can see the logic diagram too. So behavioral modeling is the highest level of substitution in where we can describe the circuit by knowing how it works. Moreover, it is additionally good news. We need to know how the logic circuit and logic diagram implements to the truth table. So when it comes to SR flip-flop, we can see the truth table 0 0. It is no change, like it will be in previous state. 0 1 will be in reset state, 1 0 will be in set state, and 1 1 will be an invalid state. So it'll be a proper SR flip flop. If you want to know, we have to know the truth table, the basic logic diagram of it to know the behavioral modeling. So T flip flop. When it comes to T flip flop has only one input terminal, where it is t is equal to 1, it toggles from its previous state and the output remains the same as the previous state. It behaves as a jk flip-flop when j and k are 1, hence it is implemented in both jk of flip-flops. So here it is a T flip-flop logic diagram and its truth table. When T is 0, there is no change. When it is on 1, it changes to the toggles. What is D flip-flop? D flip-flop can store a bit of data, hence it is known as a memory cell. Flip-flop are synchronous circuits. Since they use a clock signal using a flip-flop, we can complex as ramps, shifted registers, etc. A D flip-flop stands for data and delay flip-flop. The output of the flip-flop is equal to the input. Where it comes to D flip-flop, it has a single input and two outputs. So basically single input, single output. Basically whatever the input is there, whether it is high, the output also will be high. Whether it is low, even the output will be low. You can see the logic diagram also. So for same D flip flop also, we have to know the truth table. We have to know the shapes. You have to know the logic diagrams. So for clearance, the output will reset the triggered edge point, positive edge in this case of the clock, after the clear input is activated. The asynchronous clear the signal in independent of the clock. Here, as soon as they clear, it gets activated. The output reset they can achieve by adding and clear signal to a sensitivity. So you can see the diagram also. So conclusion, this is the considered as the highest level of subtraction in Verilog modeling. It is also known as prudential assessment, where this behavioral model provides a wide scope of designer to build and complex design with which can be probably stimulated and synthesized. So thank you today's video. Like, share and subscribe my channel.